Hello friends, welcome to our channel Piping Mantra. Today we are going to learn about how to calculate branch reinforcement connection sizes. It is a very important topic which we make use of while preparing piping material specifications and analyzing other factors like hydraulics, etc. So without wasting any time with the intro, let's quickly get to it. Now, as soon as we read the title of the video, most basic question arises as what is a reinforced branch connection and why is it required? So, when we have to cut a hole in any straight run, that is bigger size header or pressure vessel, and weld a suitable pipe piece to serve the purpose of either a stub-in, T, branch connection or pipe nozzle, we effectively ensure a hole weakening on the vessel or piping system due to the metal removed and stress concentration created unless the wall thickness of the pipe is sufficiently in excess of that required to sustain the pressure. This situation arises when we have to have a branch at a place where either standard size fittings are not available or too costly to put in the line. In critical systems, this weakness must be compensated and can be restored with a reinforcing pad to strengthen the piping branch connection or the pressure vessel nozzle. This is what we call a reinforced branch and is required to strengthen the main piping straight run. On your screens, you can see standard images of a reinforcing pad to get you some idea on how it looks like. Dimensions of reinforcement pad. For the dimensions of a reinforcing pad, you can handle as rule. First, material will be same material as the pipe run. Width will be half a diameter of the branch pipe or at least 50 mm. Thickness will be same thickness as the pipe run with a minimum of 3 mm and a maximum of 20 mm. Now comes installation of reinforcing pad. Determine the location of the branch and make a round hole in the run pipe where the diameter should be equal to the inside diameter of the branch. Finish the branch equal to outside diameter of run pipe and make a welding bevel of around 30 degrees. Place the branch with the gap by about 3 to 4 mm about the hole location on the run pipe and tack weld the branch on a sufficient number of places. Then the new branch can be completely welded. If the weld is ready, depending on the requirements of non-destructive examination must be done. Then the reinforcing pad can be placed by sliding it over the branch. The pad must be positioned so that around the branch is overall the same open space and that the pad is fully in line with the run pipe. Tack weld the pad on a sufficient number of places and after that the pad can be welded fully from inside and outside. Depending on the prescribed quality requirements, then again ND must be done. There is one important point to note, that is, sighted as a flange at the branch connection is welded, you must obviously make sure that the ring is placed earlier. Now, there is a small round hole present on the reinforcing pad, normally called as a weep hole, sometimes also called telltale hole or vent hole. Weep hole is provided at the side, not at the crotch of any pad or saddle. There are mainly two uses or purposes of weep holes. First, by threading the hole, a test gauge can be threaded for air or soap test to check for leakage. The thread, mostly 1/4 inch NPT, will be used. Second, weep holes serves as a vent during welding for entrapped gases and prevents the reinforcing pad from becoming a jacketed vessel. One thing to note of is that we need to seal these weep holes upon completion of pressure tests. If there is a non-standard connection, usually what we fabricate on site like pipe-to-pipe branch connection, it needs a calculation of strength as per ASME B31.3. It needs a calculation of strength which will tell us the additional requirements of reinforcing pad and if strength of branch fulfills the criteria of code. Here we will try to depict the procedure and calculation with an example. Let's first look at the procedure through formulas and then we will apply those in few examples so that you can get a more clear picture. Added reinforcement is required to meet the criteria as per the image shown on your screens. Available area A2 plus A3 plus A4 shall be always greater than required reinforcement area A1. That is, A2 plus A3 plus A4 must always be greater than equal to A1. If above criteria is not meeting, then reinforcement is required. Further, we will see details of calculation of all areas like A1, A2, A3 and A4. Let's first calculate required reinforcement area A1. For a branch connection under internal pressure is A1 is equals to TH into D1 2 minus sin beta, where TH is pressure design thickness of pipe reflecting to header, which is actual calculated thickness excluding melt tolerance, corrosion allowance, etc. D1 is the effective length removed from pipe at branch. Further, D1 is dB minus 2 into TB minus C by sin beta, where beta is smaller angle between axis of branch and run. dB is the branch diameter in mm. TB is the branch pipe thickness measured or minimum purchase order in mm excluding melt tolerance. C is the corrosion allowance in mm. Area resulting from excess thickness in the run pipe wall A2. A2 is defined as 2d2 minus d1 into capital TH minus TH minus C, where d2 is half width of reinforcement zone, d2 is equals to d1 or TB minus C plus capital TH plus C plus d1 by 2, whichever is greater. Capital TH is the run pipe thickness in mm including melt tolerance. Now let's calculate the area A3. Area resulting from excess thickness in the branch pipe wall A3. It is calculated as A3 is equals to 2 into L4 capital TB minus C into sin beta, where L4 is the height of reinforcement zone outside of run pipe. L4 is 2.5 into capital TH minus C or 2.5 into capital TB minus C plus TR, whichever is less. TR is minimum thickness of reinforcing ring or saddle. 0 if there is no reinforcing ring or saddle required. Now let's go to A4. Area of other metal provided by welds and properly attached reinforcement A4. A4 is calculated as 2d1 minus dB into TH. Finally, if A2 plus A3 plus A4 is greater than or equal to A1, then no further reinforcement is required. So now let's see some examples. On your screens, you can see all the given inputs with their values and units. We will use these values and calculate the size of required reinforcement and check in fact need a reinforcement in this particular example. Let's get to the calculation part. Let's calculate A1 first. Required reinforcement area A1 required for a branch connection under internal pressure. A1 is TH into D1 2 minus sin beta. D1 is dB minus 2 into TB minus C by sin beta. Sin beta is given as 90 degrees, which gives us the value of D1 as 364.4 mm. Now A1 is 21.801 into 364.4 2 minus sin beta, sin 90. So A1 is 7944.28 mm square. Let's move on to value of A2. Area resulting from excess thickness in the run pipe wall. A2 is given as 2d2 minus d1 into capital TH minus C, where d2 is the half width of reinforcement zone. d2 is equals to d1 or tb minus c plus th plus c plus d1 by 2, whichever is greater. From previous calculation of A1, we got d1 as 364.4 mm, and for another formula for d2 gives us 228.2 mm. So selected value of D2 will be 364.4 mm. Now A2 is 2 into 364.4 minus 364.4 into 25 minus 21.801 minus 0. So A2 is 1165.71 mm square. Now the area A3 is the area resulting from excess thickness in the branch pipe wall. A3 is 2 into L4 TB minus C into sin beta, where L4 is 2.5 TH minus C or 2.5 TB minus C plus TR, whichever is less. After calculating both the formulas, we selected L4 value as 62.5 mm from the first formula. Now, value of A3 is 2 into 62.5 into 21 minus 18.375 minus 0 sin 90. Therefore, calculated value of A3 is 328.125 mm square. Now, the area A4 is the area of other metal provided by welds and properly attached reinforcement. A4 is 2d1 minus dB into TH. Value of A4 is 7028.64 mm square. Total available area, that is A2 plus A3 plus A4, is 8522.475 mm square, where required area A1 is 7944.2844 mm square. Conclusion of the above example would be total available area for reinforcement is greater than required area, hence proposed pad is acceptable. I hope this video will help you. That is it from our side. We will see you next time with some new exciting content. So till then, stay tuned. Also, please like, share and subscribe to our channel. Your support means a lot to us. Drop all of your queries and suggestions if you have any in the comment section below. Till next time, bye bye, take care.